Hello guys, we got the same system that we had earlier on, same project, but instead of using an LCD screen, we are using an OLED screen, which they can see the data of the spaceX Dragon tracker, latitude, longitude, and the distance from my location. So yeah, it works based the same system. It works with the GPS and NOAA 6M, and the RX and TX are plugged into. RX is in the system supposed to be on D3 and the TX on D4, but then you change it here so that it actually pick up data and works. Okay. All right, so here's the codes. You need to upload all your libraries. You need the software serial, which uses the serial pin for the from the GPS to the microprocessor. In this case, it's the Mini Pro ESP8266. You need a TinyGPS ++. You need obviously the Adafruit. This is to initialize your OLED screen, and this is the GFX also to initialize the OLED screen. You need your Wi-Fi security for your API keys when you get them. Okay, that's the security for your API key when you receive and send information. And then the Arduino JSON, which is for to parse your data that you receive from the API, from the HTTP client website. So now the other things is I use a secret file, but you don't need to. So you can just unquote these two, okay? And you put your username of your network and your password. Please do not use my API key, otherwise they'll kick me out. So but you can subscribe and use your API key. This is the the satellite ID codes, which has got all the information that you need to manage it, to get your data. And here you initialize the OLED, it is with the SSD1306, which is the library on top, and so on. This is a Dragon. Once the screen starts, the Dragon initialize, Dragon tracker. So initialize your password and your Wi-Fi system, and so carry on, and all the way down to fetch the data from the GPS so that it can calculate my latitude and longitude, and calculate with the longitude and latitude where the Dragon is, will formulate the distance that is from me, halfway the world. And so it is, and yet fetch the Dragon data, my latitude and my longitude, and it'll work out the position. You see now it's 10,000, I think it's 10,000 kilometers away from me. I think the closest you get is about 190K, around 190 kilometers from Cape Town, so it's not that far. And the other things, it's you have your SEL. This one is SEL, goes to D1, and the SDA goes to D2. So remember, D1 and D2. I will put it on the link. I don't think I need to do schematica with fritzing, because I mean this is pretty simple, and you know there's only 2 pins here and 2 pins there. Okay, but you can use other pin if you want, for in the case of the GPS. Obviously this one you can't really use other pins because SDA and ACL, it's D1 and D2. You can make a railing, like if you got a, I don't know, maybe an MPU, and you want to use an MPU, so, and you can't fit it here, so you can fit it here, because the MPU also uses SDA and ACL. So you would put an MPU here, MPU, and then you would put the MPU ACL, ACL here, and the MPU SDA here, in case you need to. So you're practically doing a railing, like you would do the railing for the positive and the railing for the ground. Because remember, pins goes up and down like this. The current on the breadboard goes like that, except here there is no power from here to there, unless you put like that over with 1 pin here, 1 pin there, then it works. But otherwise it goes horizontally, okay, but the railing goes vertically. So if you put, you can put a lot of ground here, wire, the ground, everything. Like for example, in my case, it's grounding one here, positive, grounding and positive, and you can do the same with a lot of other products. Okay, so I'm not really teaching grounding and breadboard, but yeah. Okay guys, I think we've covered quite a bit. It's still working fine with my super wire area, because usually it doesn't work on the windowsill. Okay, have a good Monday, and thank you very much. Please, if you like, give me a thumbs up. Bye.